Okay. This is the one I want you to draw. Because this one's kind of took a little more time drawing it. Just take your time. Use your compass to make the circle. Don't hold it like that, Courtney. Only twist by the top. Lexi, I think, has the technique completely down. You lean it, push that pointing end into the middle of your page, and then you lean and spin, kind of like a figure skater. Okay, a little figure skater. That's perfect size. And when you finish your circle, I want to show everybody. Okay, this is perfect. Right here. This is a good size. This is the size. All right. Senor Morgan. Okay. Yes, I do. I want you to draw it for her. Okay. Y'all just take your time. Just label. What'd you say? Are you allowed to eat? You know the answer to that. Yes. Where is it? Is it at home? Here, Morgan. Thank you for helping, Patricia. Nice job, Maddie. Okay, Courtney, I'm going to do something that violates all of my rules. And give you one of these. Yes. Yep, radius is 1. The the radian measure is this segment of the arc. It's the arc distance. What? Let me ask you a question, okay? We have our procedure here, okay? Do you want to go see Mr. Tauber? Do you want to go see Miss Thomason? You want to stay here? Okay. Can I take this? All right. Well. Okay. Let's just let it go. It's over now. There's no group work in here. You can be as anti-group as you want. I want you to, draw everything that you see because we need to build off of that. Hey, I get it. You're hungry. Lexi, did you give any more thought to summer school? No? Maybe. Marilyn Umansor is thinking about it. Correct. No, it's an invitation only thing. It's going to be so hard that it would crush most people. Right now it's Taylor time, Taylor, and possibly Lexi. Guaranteed to be Taylor because Taylor's in Algebra 2 now. And I'm offering to a few people who I think can handle it. You can always turn me down if I approach you about it. Really hard. Like, we're going to cram an entire year into 3 weeks. We're talking about 4 or 5 hours a day of intense mathematics, followed by another 3 or 4 hours of homework. Guys, let's trust me. Most of you would regret doing that. I know that, Morgan. You have to have maintained something close to a 100 average in this class all year for me to even consider it. It's not because I'm trying to make you feel bad. It's just that I know how hard it is. And I know you guys want to get through everything fast, but it wouldn't work out. It would just scare you. Yeah, there's highlighters in the left closet. What? Like 3 weeks ago? What do you think, Ms. Moore? I'll tell you one thing that made me proud was you being kind to her. We appreciate that. We could all be more kind to one another, right? No. Yes. Well, right now, all you're trying to do is simply copy what you see. Once you copy it, I'll explain it. But I want you to make sure you got it in your notes. Looks really good. Use a different color and highlight the radius one. Or you know what? Use a color to highlight this arrow going right here. Like one of these, bro. Wait. Oh, yeah. Good idea. That is totally up to you. Oh, yeah. We're going to go over the whole thing. We going to go over the whole kit and caboodle. Just like the hours hands, the hours on a clock total up to 12. the total number of hours that you could split this thing in to are 360. Okay, imagine a clock face with 360 numbers on it, where the top number, well, instead of the top number being 12 where things kind of start, things start over here on the right side, over here. Okay, and then instead of the clock rotating clockwise, this rotates counterclockwise. So let's just look at what's happening. Caitlin Armour kind of pointed out the key feature. It starts at 0. Okay. Then you go to 90 degrees. Then you go to 180. And then you rotate over to 270 degrees. And then you rotate up to 360. You're back to 0. Complete circle. Let's look at those highlighted numbers. Yeah. 1, 2, 3, 4. So it's, imagine, if you will, unwrapping the circle. Oh, you know what? I took that thing home. Never mind. I was going to get my spool measurement out. Unwrap the circle and show you this segment. If you were to unwrap this, can you imagine unwrapping it and laying it out on the ground as a line, like taking the circle and cutting it here and just rolling it out as a line? This distance right here is, we can't measure it in like feet or centimeters or miles or light years. We measure it in radians. So it's just a unit of measure, all right? Just like you'd say, I'm 6 foot tall. There's equivalent in radians for what we call arc measurements. So this is an arc. See how it's a bended line? It's an arc. So when the circle that you're drawing has a radius that you call 1 radian. This is 1 radian. This distance right here is 1 pi over 2 radians. That's this distance. Okay, little ant walking along the curve. He's going to have to walk to get to here, he's going to walk 1 pi over 2 radians. Right? That's a number. Yeah, can you go get a graphing calculator, because you're going to help me out with something. Okay, so degrees and radians are kind of like converting between miles and kilometers, or between Celsius and Fahrenheit. Just another way to refer to it, okay? It's the same distance. This all goes back, by the way, to navigation and surveying. So this is kind of cool. I mean, I'll find a little documentary, because in geometry, we don't have a lot of pressure on us to just keep the iron pressed to you, like, work, because there's no STAR test. So I'll try to show you a little documentary that teaches you, why is this? Like, why? It's all about navigation, navigating the oceans, mapping, creating the longitude and the latitude systems that we use here on our maps. And basically, navigators needed a really good way to use the position of the sun and the stars to find out where they were on the earth. And so they invented this. Okay? So the reason pi is showing up everywhere is because it's a circle. Right? So whenever you see a circle, pi is going to be involved somewhere. And pi is involved everywhere here. So, if you're a fat guy like me, you love this. I love that dead silence. That's pie. I like to eat the pie. Pecan pie, cherry pie, key lime pie, blueberry pie, peach cobbler, okay, with ice cream after you heat it up. Oh yeah, with a little cinnamon on top. One of those little things that you get at BJ's. You know what I'm talking about? It's like a cookie served in a pan that's hot. You can get it different flavors, but I usually get the Oreo or chocolate chip cookie. All right. So here we are. We're walking along the edge of the circle up here, and now we're at 90 degrees, 1 pi over 2. This. 90 degrees is 1 pi over 2 radians. Just like you'd say, 1 mile is equal to such, what is it, 2.2 kilometers? Or is it the other way around? Kilometer is shorter than a mile. Yeah, so like I think 1 mile is equal to 2.2 kilometers. 90 degrees is equal to 1 pi over 2 radians. Okay, so we keep walking. We're doing our little marathon. And we go over here. And now we're at 2 pi over 2 radians, or 180 degrees. Those are the same thing. You could write 180 degrees equals 2 pi over 2 radians. Okay? Continue walking. Now you're at 270 degrees. You're standing upside down. Your hair is hanging down. Okay? You're using those Tron magnetic feet to stand up, down. All the blood is rushing to your head. All right. And now you're at 3 pi over 2. So we went from here to 1 pi over 2, to 2 pi over 2, to 3 pi over 2, and back to 4 pi over 2. Okay? Now we're at 360 degrees. This is a number. And Morgan, what I want you to do is turn on the calculator for me. We are going to calculate the decimal radian approximation. Here's the reason why we have to always round or approximate when it comes to radians. Because pi, 3.14159.265, etc., etc. It goes on and on and on. What type of number is that? Never repeats. It's an irrational number. Okay? It's irrational. So anything that you're going to do with pi, you're going to divide it by 2, you're going to multiply it by 2, then divide by 2, multiply it by 3, then divide by 2, multiply it by 4, then divide by 2. Okay? Anything you're going to do with pi is going to end up being an irrational number. So, Morgan, can you please put in alpha y equals enter? And then you got a little fraction. Put in 1 pi in the top and then 2 in the bottom. And the pi symbol is second. Okay. 2 in the bottom. Hit enter and let's see what the decimal is. Okay, let's just go 3. 1. I want you to write this. So we're going to add to our graph right now. This 1 pi over 2 equals 1.57. We'll just go to 2 decimal places. 1.57 radians. Let me at 1.57. Radians. I'll write it out. I'm going to write it out here. So both, whoa, okay, that scared me. Both 90 degrees and 1 pi over 2 are equal to 1.57 radians. Okay. Now, Morgan, well, we know what pi is. We don't even need Morgan to put that in the calculator. So the radian measurement when you're at 180 degrees, it's just pi. So can you tell me pi to 2 decimal places? 3.14, because that's what pi is. If you hit pi on the calculator and then hit enter, it's going to say 3.141592. Okay, so we're just going to say 3.14 radians. I just memorized it. Morgan, as a socially isolated dork, fat boy, as a teenager, I had a lot of time to just sit alone in my room and memorize useless trivia. No, I was not skinny until I was in my 20s. And then I got really, really like fit and skinny. And you've seen the picture, right? When I was really thin. And then when I came here, I was hugely overweight when I first came here 3 or 4 years ago. And then in that first semester, I lost like 50 pounds in 3 months. Do you remember that? No. And then what happened was the STAR test, when I started to get involved with that, it just, I started stressing a little bit. But what really did me in, guys, was that injury. Yeah, that did me in, because instead of moderating my diet to accommodate for the fact that I had basically ceased all physical activity for 6 months, I just kept eating. So now I'm on the downhill slope. Listen, you can work out until the cows come home, and after a while, you're only going to be able to lose a maximum of like 2 pounds a week on a good. Otherwise, you're kind of overdoing it. So I'm hoping that that we start to see some declines in the weight category. Yeah, but I could be a lot smaller. All right, I'm about twice the size I was in December of 2017. So. Okay, now let's do this one. Morgan, can you please put? Morgan? Can you please put 3 pi over 2 into the calculator? Yeah. Alpha y equals enter. 3 pi on top, 2 on the bottom. Uh-huh. 4.712. Oh, we'll go to just 2 decimal places. 4.71 radians. Okay. And then, guys, when we get back to 4 pi over 2, that's just 2 times pi. So if pi is 3.14, then 2 times pi is just 6.28. So this is 6.28 radians at 360 degrees. We also say that this is 0 radians because this is where we start and end. So depending on what you're doing, you'll either think of that as the 0 radian mark or the 6.28 radian mark. So we actually, guys, up on the board right now, there are 3 separate ways of referring to each of these 4 points. We have our decimal approximation. We have our pi exact radian. And then we have our degrees. So where that, what we did at the very beginning of class yesterday, where we converted from degrees with decimals into hours and minutes and seconds, what we need to learn how to do next is convert from these radians. Okay, here's what I had Morgan just stick this in the calculator. Yeah. Okay. What the goal today is not to go any farther than merely understanding that this is the perimeter length, the circumference. Okay, that's what the perimeter of a circle is called. The circumference of a circle with a radius of 1 radian is 6.28 radians. That's all I'm trying to get across to you, ladies and gentlemen. 6.28. Well, that's it. That's it for this moment. Let me tell you that you're on the right track. Okay. So what we're going to do now, so we found the distance at 90 degrees, 1.57. Okay. It makes sense that it's 1.57 because it would be longer than the radius itself. See, this would only go to about here, so it's going to be a little bit longer than the radius. So 1.57, that's 90. 3.14, that's 180, right? 4.71, that's 270. 360, it's 6.28. So if somebody asked you, how about 720 degrees? Well, now you've just rolled out 2 circles back to back. And that would be 6.28 times 2. 720 is 360 times 2. So you see how you can just start going further with this. But if someone asked you, because this is 360, if this is 360 degrees, if someone said, okay, if 360 degrees with a radius of 1 is a length of 6.28 radians, how far would I have to walk to get 720 degrees? Well, you would just have to walk double this. Okay? Oh, okay, so here at this point, this is both the start and the end of the road. It's a circle. Okay? Now, what Caitlin asked is a great question. Caitlin, do you remember what you asked? What'd you ask? Yes. So the way I'd like to answer that, and that was such a nice segue into what I wanted to teach you. So we've calculated these 4 radian measurements at 90, 180, 270, and 360 or 0 degrees. Now we're going to calculate the radian measure in both the exact pi form and in the decimal form for 1 degree, because that's going to answer Caitlin's question. If we know the radian measurement for 1 degree, and then I ask you, what's the radian measurement for 37.25 degrees? You would just take the radian measurement for 1 degree and multiply it by 37.25, wouldn't you? Oh, okay, that's kind of interesting. Okay. So 1 degree, it's going to be really hard to draw. It is a very slight angle. Yeah, it's really basically impossible to draw. And remember, guys, there's 360 of these. So you'd have to imagine a pie cut into 360 pieces. If you watch that video, it's like 2 hours long. I actually do it. Yeah, because I have no life. Okay? We broke up. Let's not get into my private life. I mean, who cares, right?
I was
Okay. So this is 1 degree, right? We'll just call this 1 degree. First, I want you to multiply that by 2. Wow. Okay, what is 1 times 2? Now I want you to multiply that times pi. Just leave it as pi, okay? And Morgan's going to do our calculating here in a moment. Now, what I want you to do, right? Now what I want you to do is divide that by 360. Okay? So what you get if you reduce this fraction, 2 over 360 can be reduced down to 1 over 180. So you can write 1 degree as pi over 180. Or the way I like to write it as 1 degree times 2 pi over 360. Because that to me is, now that's for, because I always know what the degree number is in that way. Morgan, did you get the decimal approximation of that? We're going to do 1. So in alpha y equals, enter, in the numerator put 1 times 2 pi. And then in the denominator put 360. So Morgan's about to give us the decimal approximation of the radian measurement of this little tiny itty bitty piece of the arc. Right? Whoa. Right? Whoa. Right? Whoa. Now I'm changing this line. I don't know what I'm doing anymore. Can you show me the calculator? 0.02. Oh, so 0.01745, whatever. Yeah, we were gonna round to 2 decimal places. So it's 0.02. 0.02 radians. So now I want to show you the power of what you have available to you. You can now tell me the angular distance of any degree. So I just want to ask Samara, I need you to give me a number between 0 and 90. 4. Noah, I need you to give me a number between 0 and 9. Enria. Yeah, 9. I wanted it 9. Enria, can you please give me another number between 0 and 9? 7? Okay. So what we're going to find out is what is the radian measure of 45.7 degrees? No, I wanted y'all to participate. Try to make it a little bit more interessante. So I'm not going to be able to get this at fractional degrees. So I'll just draw this in. Okay, so this is, come on, watch this and you'll understand a little bit more. 45.7 degrees. Okay, remember how we do this, guys. We take 45.7 times 2 times pi, that's all in the numerator, over 360. That's going to be, I'll do the alpha y equals, enter, 45.7 times 2 times pi, all over 360. So I guess I should say 0.8 radians. Okay. That means that this distance right here is 0.8 radians. Okay? So if anyone asks you, what is the arc length of 45.7 degrees, you tell them, you know what it is? It's 0.8 radians. I don't know. Now, you could reduce that fraction down to 40. Whoa. You could reduce this fraction the way, you know, the book would probably do it is 45.7 pi over 180. Because you can always, if it says 2 over 360, you can always reduce that down to, where'd the 8 go? Oh, I deleted it. I'm sorry. There we go. 0.8 radians. Okay. So let me ask this question now as we close our class for today. I'm sorry. Lo siento. Okay. Do you folks have a has your anxiety and misunderstanding, or has it been reduced a little bit? Okay. Well, for JC, this is the first time she's seeing this, so. I was in a little bit of a mood yesterday. I'm sorry. I didn't get much sleep. Yes, go get the ice. Sorry, Morgan. Where are you going next, Morgan? I'll write you a note. Oh, he'll be okay with it. I'll email him, okay? I'm sorry. I'm having a hard time in algebra. Let's just ixnay with the jeez. Good Lord, we're on a live mic.